Yeah. Like you don't even know what you're Stop talking.
All right, you guys turn to page 7 in your packet. Some during lunch. All right, so we're going to practice these area formulas from calculator perspective. So you guys can have your calculators out. Preferably graphing calculator. Okay, so this is a FRQ problem from an older test. But the reason that I like this one is because this we get to practice all the variations of top minus bottom, right minus left, having it split up into multiple regions, and really getting a feel for how the area formula can be created. So we have R and S. Let R and S be the regions in the first quadrant shown in the figure. The region R is bounded by the x-axis, and the graph of y equals 2 minus x cubed. That's the curve that's sloping down. And y equals tan x. Tan x is the curve that's sloping up. Region S is bounded by the y-axis, and the graphs of y equals 2 minus x cubed and y equals tangent of x. We're going to first find the area of S. Now, on the AP exam, this problem wasn't split up into these 4 parts, but I really want to take advantage of this problem and I identify all the different ways of solving region S and region R. But on the AP exam, if there were multiple ways to solve it, you can just choose one way and solve it the way that works for you. But for now, we're going to practice all the variations. So we have 2 formulas. We have either top minus bottom or right minus left, or top minus bottom. Every expression has to be in terms, has to be a function, has to be y equals, and everything you insert has to be in terms of x. If I want to do right minus left, my equations need to take on the form of x equals And then everything that I insert in has to be in terms of y, and my bounds are also in terms of y. But first thing is we're gonna graph. Okay, we're gonna put this in our graphing calculator and actually see if we can get this graph to show up. Okay. So your calculator, you're gonna go to y equals upper left corner here. Yeah, sorry, I can't make it any clearer. So we're gonna go ahead and type these functions in. So we have tangent of x and 2 minus x cubed. Now I do want to make sure that anytime you're graphing trig functions, you're always in what mode? Always in radian mode. Okay, always in radian mode. Okay. So basically on the AP exam, you're always in radian mode. You never have to switch over to degree mode. But it only makes a difference if you're dealing with trig functions. Okay. So let's go ahead and type these functions, and we have y equals tangent of x. And then under y2, I'll put 2 minus x cubed. Now, we can adjust the windows later, but right now, if you go to Zoom 6, it'll get you a negative 10 by 10 window. And it may be too zoomed out, but we'll deal with that when we get to it. So go ahead and hit Zoom 6. And it's just going to be, but if you look at the diagram that we have, it's just the first quadrant. And it's just that little region that we see there. So we really want to kind of zoom in on that region. Now, there's a way that we can, anybody have issues getting this graph to show up? Question. Oh, x cubed, minus x cubed. Okay. Now, we can adjust the windows ourselves, but we can also use this feature here. If you go to Zoom, you see that Z box. So you can click on that. So Zoom 1. Now there's going to be a cursor, and you're going to move. Sorry, you're going to move the cursor to where you think is the upper corner of your box that you want to be. So maybe you move the cursor over here. Then you'll hit enter. When you hit enter, you can drag a part of the box over, and then you go down, and it's going to stretch the box out like this. So that's the goal. You want to kind of create a box that you want to zoom in on. So, okay, so let me show you here. So I'm going to scroll to where I think is the upper corner, where I want my box, which is, and I hit enter. And then when you scroll over, you're going to see a line form. And then you're going to go as far right as you can, where at the width of your box. And then if you scroll down, you can see the box form here. And if you hit enter again, then you should be able to see a zoomed in picture that should resemble what you see on your paper. Yeah, so you're going to do Zoom 1. So Zoom box, it says Z box. Do you see that? Zoom 1.
Does that have to be?
No, just as long as you can see, you're just trying to make it look as close to your paper as possible. Hit enter. That should give you a zoomed in picture. Mm-hmm. Yeah, for some reason, sometimes the plot is highlighted, you just want to go up. Guys, I do want to point something out here. If you go to y equals, sometimes students have trouble plotting their graph because do you see how above y equals 1, there is a plot 1? Sometimes that plot 1 is highlighted for some reason. I don't know exactly why. Maybe because of other things that you've done in the calculator. So if you're having like dimension errors, go up to plot 1 and unhighlight it. So a lot of times that plot 1 is what's causing the graph to not be able to graph. Okay. All right, so everybody okay getting a graph that looks like what you see on the paper? So we're going to need the intersections to help us with the rest of the problem. And so you're going to go to second trace, and you're going to select the option intersect, because we're going to look for the intersection between the two order pairs, and we're going to find those intersections. It's going to be really helpful for the rest of the problem that we're doing. So intersect, second trace, you see that? So if you do intersect, now you're going to ask the calculator to find the intersection of two graphs, but you're just going to tell the calculator, I want you to find the intersection between this graph and this graph. So hit enter, hit enter, and then you see the word first curve. And if you toggle, you're going to see that you can jump back and forth between the two curves. Okay. So I would just stay on one curve and then just get relatively close to your intersection. Don't have to be that close, but relatively close, hit enter. So the calculator knows, okay, that's the first curve you want to consider. And then second curve, you're going to go to and the cursor should jump to the other curve. If it doesn't, you can just toggle up and down, hit enter again. And now the calculator is going to find the intersection for you. So you see the word guess question mark, hit enter again. It's going to get that intersection for you. So write that order pair down on your paper, 0.902 and 1.265. I'll come around and help you guys in a moment. And both the X and Y values are going to be helpful over the course of our 4 diagrams, but let's go ahead and gather as much information as we can. Again, I'll come around and help you about, let me just get through some of these things here. Now, we also, another important thing is, I mean, I know we're only looking for a region S, but let's go ahead and get everything that we need for both region S and region R. Another boundary that we see is where the graph of 2 minus x cubed intersects the x-axis. So if we want to find that intersection there, we're going to go to second trace. And now we're going to look for a 0 because it's where the graph hits the x-axis. So now we don't want to do an intersect. Intersect is if you're looking for intersection between two curves, but here we just want to look for an x-intercept. So hit second trace 0. And now we just want to stay on that curve that is that downward slope. And you're going to pick a point to the left of the x-intercept. So basically above the x-intercept, hit enter. It says left bound, hit enter. And then you're going to scroll to a point on the other side of the x-intercept, hit enter again. Guess question mark, hit enter. And it's going to find that x-intercept for you. So that's going to be a helpful information that we need, 1.259. And then one more thing that we need is we're going to need that y-intercept. That y-intercept will be useful for us. So I think you may just be able to scroll, hit trace, and just scroll over to that point there. You may have to toggle between the two graphs. The one up on that y and the y-axis there. And it should be right at 2. See that 2.000. So you know that's a y value of 2. Okay, so we have everything that we need. Let me come around, see if any questions. trace. I'll go to this graph.
Oh, I pressed it. So there's.
Yeah, that's pretty accurate. That's gonna be a whole number. I did second trace and I did 0. Then I think the points go left, the exam session. If the point was a right, the exam session, and it's 6.
And usually it's the second, like the one.
The one is just, I did trace,
No, last you're having a.
and I just scroll over to that point. So it's yeah, I think it's soon. I'm just, I was just lost. Oh, you're even. And then you can do zoom. Zoom box, zoom 1, and then draw a box in that region there, right? Okay, so now we have everything that we need from the calculator. Let's go ahead and set this up. Okay, so let's go ahead and set this up. So we're going to look at region S, area of region S. Okay. So I'm going to go ahead and highlight this region. We're going to start with the easier one. Okay, so this one is going to be top minus bottom. And let's go ahead and draw a representative rectangle. Okay, vertical rectangle. Now imagine I have really, really thin vertical rectangles that extend from one end to the other. I'm just looking at region S. Is it consistent? Is the top of every imaginable rectangle hitting the same curve? Yes. Is the bottom of every rectangle hitting the same curve or hitting the other curve? It is, right? So we can rely on one area formula to do top minus bottom. So let's go ahead and set that up. Okay. Let me use a highlighter so I can see these a little more clearly. So the graph that is sloping down is my 2 minus x cubed. Okay. So area equals definite integral from, now we're following the top minus bottom, so everything has to be in terms of x. So we want to go from the furthest left to the furthest right. What's the furthest left x value that you see of this region S? 0, right? So we're going from 0 to what's the furthest right x value that you see for region S? 0.902, right? 0.902. Okay, we don't want to use the 1.259 because that's not part of region S, right? Region S only goes as far as 0.902. Okay, so we want to pick the top graph and then we do minus the bottom graph. What's the top graph? Yeah, 2 minus x cubed. Minus the bottom graph is tangent x. Now, yes. We could. The reason why I decided not to is because there's only one term, so it's not that important. But if there were multiple terms, like if it was like tangent of x minus 4, then I would definitely do the parentheses there to make sure it distributes. Because there's no negative sign in front, so we're safe. Yeah, it's only if there's a negative in front that we have to make sure we distribute. Otherwise, the signs will be messed up. All right, so we can definitely type in exactly as you see it. So if you do math 9, you can type that in. You got to do quit. So you got to go to second mode to go to quit, and you do math 9. Type in everything that you see. Now, I do want to show you something here. We have these two functions stored in y1 and y2. So I think, let's see, if you do alpha, you're right, alpha trace, thanks. So alpha trace So my top function is stored under 2 minus x cubed. Now, it may not be that time efficient to do this with such a small function, but a larger function, it's good to have this option available. So if I do alpha trace, I can pick y2. That's my top function. Minus, and then alpha trace, pick y1. That's my bottom function. Dx. Make the calculator do all the work for us. 1.161 is the area of region S. Anybody having trouble with getting this answer here? If you have an older calculator, you're gonna have to enter things in using this notation. That can help you later if you're needing help with that. Okay. Now, this is obviously the more preferred method, top minus bottom. Everything's already set up for us, but for practice purposes, I want us to find the area of region S, which will always still get us the same area value, but from a right minus left perspective. Okay, a lot less efficient, but I think it's good for us to practice and see all the things involved with right minus left. Sometimes a problem forces you into a right minus left situation, so it's good for us to practice that. So again, highlight region S. And let's go ahead and draw representative rectangles, horizontal rectangles. Okay, along this region here. Yes, we are. So the bottom half where we're going to do region R. Yeah, but right now we're going to focus on region S. Okay, so now let's say we're stacking horizontal rectangles instead of vertical rectangles. As you can imagine, these horizontal rectangles stacking from the lowest to the highest region of region S. What do you notice? Are the rectangles all hitting the same graph all the way through? Okay. There's a change, right? There's a change. So I'm going to use a different marker here. There's a right minus left for above the intersection, and there's a right minus left for below the intersection. So we're going to have to create two separate formulas, two separate area formulas. Now, on top of that, there's more things that we need to do, because if we want to do right minus left, our equations have to take on the form of what? X equals. So these equations that we see are not suitable for right minus left. We have to rewrite them in a different form. Okay. So if I want to solve for X, okay, so tangent of X equals Y, how can I get X by itself? I have to do what? X equals, how do I move that tangent over? Not Y divided by tangent. Inverse, yeah. So X equals inverse tangent of Y. You pass. Okay. Now we also have to rewrite this equation, right? This Y equals 2 minus X cubed is not suitable for right minus left. It's perfect for top minus bottom, but it's not in the correct form for right minus left. So we need to solve for X. So I have, if I move that X cubed over to the left side, I get X cubed is equal to 2 minus Y. And if I want to solve for X, what can I do? Take the cube root. Okay. Now, not only do we have to make those adjustments, our bounds need to be in terms of what? In terms of Y, which is fine because we have everything that we need, right? We have all the Y values that we need for all the region S. So let's start at the bottom and move our way up to the top. Okay. So I'm going to start with this region first, the yellow tangent and the x-axis or y-axis. Oh, and then what's the equation for the y-axis? x equals 0. Right, x equals 0. So you have all these equations that are in the perfect form that we need for y minus left. You got x equals 0. You got x equals inverse tangent of y. You got x equals cube root of 2 minus y. Okay. All right, so let's set up our area formula. Area equals. Let's do the bottom region here. Definite integral from 0 to, what is the y value at that intersection? Wait, halfway, right? We want to just go halfway up this region here. 1.266. Okay, right minus left. So the graph on the right is, for the yellow, inverse tangent of y, minus the left graph. What's the graph on the left? 0. We'll close that off. That's my first formula, plus depth integral from, now let's pick off the upper half region of region S. I want to go from 1.266 to 2. Good, right? So everything, we got to make that adjustment. Everything's in terms of y here. All right, right minus left. So the right endpoint of my region here is cube root of 2 minus y minus 0. Okay, now given the choice, not many students will choose this method, but it is good, very good practice for us to get used to this orientation. Now, in your calculator, right, this is what you put on paper, but in your calculator, you're going to enter everything in as what? X. Good. So the calculator, you're not going to make the adjustment in the calculator, but on paper, you just know that everything's in terms of y. Okay, so I think this one is easier for you to just type everything in. I don't think it's worth the trouble to graph it in this. Yeah, so we're just going to type everything in, starting with math 9. And we should get the same answer as part A, right? Because we're dealing with the same region here. Yeah, cube root, if you do math 4, I think math 4 will get you the cube root. All right, so double check in your calculator. We should get the same answer. May take a little bit longer, but 1.161. Okay, so I want you to notice all the adjustments that's needed for right minus left. I know it's easier for us to just use these equations in front of us, but the tangent x 2 minus x cubed is not in the proper form. So not only do we have to split up into individual problems, we have to make the adjustments with the bounds as well as the equations. Good. All right, let's move on to region R. Now let's do the top minus bottom method for region R. So imagine drawing vertical rectangles. Okay. Now, if I have all these vertical rectangles stacked from one region to the other region of region R, is the top of every rectangle hitting the same curve?
No.
It's not. So that means I need to do what? Split into 2 formulas. Okay. So again, I'll use highlighter to show the change. Okay. The nice thing about top minus bottom is we can hold on and use these equations that's in front of us. But we do need to set up 2 separate integrals. So now we're dealing with region R. All right, so the first region from 0 to what? What's that x intersection there? 0 to 0.902, yeah, in terms of x. All right, the top of that left region is that have it highlighted in yellow there. That's the tangent x. So tangent of x minus what's the bottom of the rectangle hitting? 0. Yeah. All right, so that's the left region. And then let's move on to the region to the right where we see past the intersection where we pick up the pink curve, the 2 minus x cubed. So from what? 0.902 to this intersection, which is, yeah, 1.259. Top minus bottom again. 2 minus x cubed minus 0 dx. All right, everybody good with, now, we don't need those zeros there. I just wanted to put those zeros there to see that we're following the formulas, right? We're doing top minus bottom, that's, and that we are completing the area formula. But on the test or quiz, you don't have to show that. I just want to show it for matching with the rule. Okay, into our calculator it goes. You guys get 0.729. Okay, so let's look at region R from a right minus left perspective. So I'm going to draw a representative rectangle here. Can I just rely on one formula to get to the area of that region? Yes, so that's good, right? So we already have everything from above. We can just carry that down. It should be a quick area formula because we have everything that we need from above. So we're stacking these horizontal rectangles from y, lowest y value 0. What's the highest y value? Yeah, 1.266. Right minus left. Now we can't use the 2 minus x cubed and tangent x, right? But it's okay because we already gathered those adjusted equations from above. So what's the curve on the right? Cube root of 2 minus y. And the curve on the left, inverse tangent of y. Okay. You see y's on the paper, but in your calculator, you're going to use x's. We should get the same area because we're talking about the same region. Okay, let's try number 2. So let's see if we can practice graphing everything that we see in number 2. And I want to walk around, make sure if you're having trouble with your calculator that I can help. All right, number 2. All right, so let R be the region bounded by the graph y equals e to the 2x minus x squared. and the horizontal line y equals 2. You see that horizontal line here. And let S be the region bounded by the curve and the two horizontal lines. So we see that it is that middle portion is region S. Okay, so let's find the area of R. So what we can do is we can find the intersections between y equals 2 and the curve, and that should be pretty straightforward. So let's go ahead and type in our equation here. Y equals e to the 2x minus x squared. Okay, and then under y2, I'm going to type in y equals 2. Again, I'm going to do zoom 6 just so I can get my standard window. But if it's not what I want to see, then I can always make the adjustment later. So zoom 6. It's a little small, so I'm going to do second trace. Sorry, I'm going to do zoom box. So zoom 1. See that Z box? And then I'm just going to go to the upper corner of my diagram. Hit enter. And then scroll to the right, and then you can begin to see your box being drawn. All right, so I just want to find the area of that upper region. So I'm going to find the intersection between my two graphs. So I'll do intersect. So second trace, intersect. Now you do want to pick a point close to you see there's two intersections, right? So you want to pick a point so the calculator will know which one that they wanted to ask. Now you don't want to go directly on the intersection, just pick a point close to it, hit enter. And then second curve is the horizontal line, hit enter again. So the calculator knows that, okay, you want to find that this intersection, not this one, because you're closer to the one on the left. Hit enter again. So 0.446. So we're going to repeat the process. Second trace, intersect. Now I'm going to pick a point on closer to the other intersection that I'm looking for. So scroll over to a point close to the intersection, hit enter. Second curve is the line, so that should be close as well. Hit enter again. It'll find that intersection for you. 1.553. Or I'm going to round to 1.55. So it's either is fine. All right, so this area for part A should be pretty straightforward because we can just do the definite integral, top minus bottom, from 0.446 to 1.554. Okay, what's the graph on top? The curve, right? What's the graph on the bottom? 2. Yeah. Second mode will get you back to your home screen. Alpha trace, you can pick your graph. Okay. Now for part B, find the area of region S. I think one way that we can do it is we can split it into 3 regions and find the area of this region, area of this region, area of this region. That's perfectly fine, but I think there is a more efficient way of getting to region S. what if we did this? What if we found the area of this? And then do what with that? Yeah, subtract R, right? I think that's could be more efficient because then we can just ignore this. And this is the top curve, this is the bottom curve. We find the area of this region from here to here. And that will give us the full region, subtract the 0.514, and then that will leave us with region S. But you can definitely, if you want, you can definitely still split up into 3 regions and do 3 separate intervals. It's just not as efficient, but it's, but let's practice the one where we can use just 2 or just one, just a 2 area form. Okay, so I'm going to focus on getting to the area of this entire region. Now we know one of them is 0, so we just have to figure out the intersection between the curve and y equals 1. So I'm going to put in the third graph here, y equals 1. Oh, and then if you don't want to see the y equals 2 graph, you can definitely have it not show. So if you go to the equal sign, you can hit enter, and then it's going to leave, it's no longer highlighted, which means that it's still in the calculator, but it's not going to show up on the graph if you don't want it to. Go to the equal sign and hit enter, and then it'll unhighlight. So this is my y equals 1. I'm just going to look for that intersection between the curve and y equals 1. So second trace, intersect. Okay, go get close to the intersection. Second curve, hit enter. So, oh, it looks like it's right at 1. Okay, so. All right, so let's find the full region, the full highlighted region, and then I can subtract out region R. Okay, so the top curve is the exponential. The bottom curve is the 1. I'm sorry, not 1, it's 2. I bet it's right at 2. Sorry. Okay, so I got 2.0601. I can just subtract the answer from part A. Okay, so after I make that adjustment, subtracting that upper hill, I have, or the upper hill region, I have 1.546. So what we just did with our calculator, that's really, I would say, the most important calculator skills that you need for AP exam. It's not going to extend beyond what we did with the, because we've explored all the features that you could see, most of the features that you're going to see from a graphing perspective on the AP exam. So it's good exercise for us to go through with that. Okay, you guys have homework from the textbook again, 7.1. There's some more FRQs. We'll try to hit those over the course of this next week. You can get back to them. All right, go get your phones. All right. Yeah. Great. Thank you.
And people have to do it.